CloudDB, shaping your new normal.
Welcome everyone to the 2022 APAC OCI Days by Apaco UC. This is our first year having a dedicated OCI event, and it's our honor and privilege to run this event with the support of 15 Oracle user groups and Java user groups in the Asia-Pac region. Please remember to register to as many sessions you can. This way you will be able to access our replays until June 15, 2022. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, the Oracle Ace community, the DevRel team, and your main sponsors, Oracle Corporation and CloudDB. Now for today's session, Delivering Database as a Service with Kubernetes Operators by Ron Ekins. Please feel free to ask questions at any moment by using your right lower corner of your screen where the chat window is if you're using the live webinar platform. If you're watching through the streaming of live Facebook with some of the user groups streaming live, please feel free to add your questions directly in the chat window on the Facebook Live, and the moderators will let us know of the questions at the end of the presentation.
Hello.
If you have any issues or problems during the presentation, please use the same chat window to let me know, and I will try to help you the best I can. Now, without any more further ado, I want to leave you with this amazing session by Ron Ekins. Ron, the room is yours.
Thank you, Francesco, and welcome to my session, Delivering Databases as a Service with Kubernetes Operators. So this is me, Ron Ekins. I'm a Principal Field Solution Architect working in the Office of the CTO at Pure Storage. You can see my Twitter handle there, at Ron Ekins, and also my Oracle theme blog at ronekins.com. So I try to have a lot of current content on there, lots of stuff on Oracle Cloud and Kubernetes and traditional Oracle technology. So please take a visit there. I'm an ACE director and also a TOGAF certified enterprise architect and cloud architect. So the agenda today is Oracle containers. What have Oracle been doing in the container space? You may not be aware of that. Look at quickly support and licensing. So before we always move forward with a new technology, we should make sure we understand the licensing and support requirements. And then we'll look at database operators, and in particular the Oracle database operator, which is quite new to many people. Okay, Oracle containers. So Oracle's actually been supporting containers for quite a long time. The first release was 12.1, and then 12.2 came very quickly after that. And that was released via the Docker Hub. That's no longer available. It's been deprecated, and you should now go to the Oracle Container Registry. On the Container Registry, you can see 19C and also 21C. So these are Oracle-provided images that you can use as is. You still have the same support requirements and licensing requirements, but these are available via your single sign-on in the Oracle Registry. So if you visit container-registry.oracle.com, you'll be able to navigate into the repositories and see Enterprise, Instant Client, Rack, Standard Edition, and the database versions. So that's great. So they've got these pre-built images which we can use as is. However, that's not always what we want to do. Maybe there's versions that aren't available in the repository. So Oracle also provides a way of creating our own. So Oracle has a series of build scripts which are available in GitHub, and you can navigate those and find scripts for 21C, 19C, 18C, and these could be Enterprise Edition, Standard Edition 2, Express Edition, as well as some of the older releases like Oracle 12, Release 2, and also even 11G. So we can actually build any environment now and deploy that as a container, which is really good. You do need the Oracle images to do these. You can't, and you shouldn't really be visiting sites that have an Oracle image made available to you. You should only ever use Oracle images provided from the Oracle site. You always want to make sure that you're using a trusted source. The Express Edition, however, will pull the Oracle images back for you. So that's a container. What's a orchestrator? So an orchestrator manages our containers. So Kubernetes is one of the most famous orchestrator, and its job is to make the desired state the actual state. And it does some things for us on the container side. It manages work placement. It manages state. It keeps things up. It keeps things running. It load balances the service. It sorts out networking, manages persistent storage, and it's a declarative mode. So this gives us the ability to say what we want, and then Kubernetes makes it so. Oracle's helped us use Kubernetes by having a Helm deployment. So the Oracle database images can be deployed into Kubernetes with Helm. The Helm chart is really easy to use. So you install the database into the cluster with Helm install. So standard Kubernetes syntaxes. The Helm charts are public again. They're on GitHub, and they support customizations and extension. So I've done a blog on this, but it's very simple. So if you've never used Oracle and Kubernetes, it's a great way to start. So the Oracle Helm install is you clone the repo back to your machine. You can then, if you have Helm installed, otherwise you have to install it first. Once it's installed, you can then do a dry run install and then install. So we can see there the syntax, Helm install the database, and then I have a values file which specifies the database name, password, and other configuration, and then the image that's been created from the package command. So very simple to deploy, very powerful. And as I say, if you want to learn more about how to use Helm, visit my site and I'll give you a walkthrough there how to do that. Okay, so I said you always need to consider support and licensing. So why is Oracle's position on this? So actually, it's very similar to how Oracle supported VMware in the early days. So Oracle does support databases running in containers, and it has for quite a while, actually. And we can see here, these are the latest support notes. For single instance, Oracle does support customers running single instance in Docker containers. And there is a separate note for rack. And rack is also supported since 12.2. But more recently, it's been updated as of the end of last year. And this is the current position for support. So we can see Oracle 21.3 is supported for rack in production. 19.3 dev and test only. So for many users, that's good enough. You can run 19.3 in development test, become familiar with containerization, and if you want to go to run containers for production, you can do single instance today, but if you want to run rack, you have to upgrade to 21.3, and then you can be fully supported. So what about licensing? So Oracle has a really good paper on how to configure your Kubernetes cluster for licensing, and it's very similar to the VMware world. So you have to license the physical server, so you need to control where your Docker image is going to be running in the Kubernetes cluster. So you pull your image back, and it runs on a worker node. So you have to license the number of worker nodes. Kubernetes has features, and this document even talks about those, how to use some of the topology features so you can control where the image runs. So if you have a 1,000 node cluster or 100 node cluster or even a 10 node cluster, you might not have that many Oracle licenses. So you actually manage to say it will only run on these nodes. Very similar to the concept we have with VMware, where we control where it's deployed. So this talks about the database operator. So what are database operators? So Kubernetes operators provide a way to package and deploy and manage Kubernetes applications. The operators help us deploy applications in a cloud-native fashion, automating through Kubernetes, and lots using the Kubernetes features to do deployment management, scaling. Also, it should be backup and location independent. So we should be able to do all the features we expect from a database through an operator. The operator is powerful because it allows us to deploy in a consistent manner. So we can actually deploy on premises or in the cloud using the same commands and across multiple cloud vendors. However, the caveat being that you can only run Oracle RAC in the Oracle Cloud. Even with VMware, you can't and you shouldn't be running Oracle RAC in a non-Oracle cloud. Obviously, on-premise is fine. So Oracle has a number of operators already. There is a times 10 operator, and there's been a recent announcement about times 10 being able to use this in the same way we can use Express Edition. So that's really exciting. So we can all go now and play with times 10, the in-memory database, and there is an operator for that. Oracle also have a operator for MySQL. It's not production yet, but it is going to be fully supported by the Oracle Corporation. And here we can see the note where so it's publicly available on GitHub. In the MySQL world, there are lots of other providers, and if you go to the Operator IO hub, you will see many MySQL operators. So you need to check the features that you require of an operator, whether they match that operator's features, whether they be for Percona's one or the MySQL operator. So the operator, whether it be a times 10 or an Oracle or MySQL, it manages this life cycle. So setting up the environment and then managing day-to-day operations on it. So if you're thinking about an operator and you're going to decide which operator to use, really you need to define a list of functional requirements, as well as non-functional requirements. But let's look at the functions that we want out of our container to deliver database as a service. So our operator should be able to provision and delete environments. That has to be the starting point. If it can't do this, well, we have to do this outside, and we can do this with stateful sets, or we could do that with deployments. But our database as a service, database operator, we're looking for it to do automated provisioning for us. And then when we finish with a system, be able to retire it, and so delete the environment. We should be able to stop and start services. We also should be able to deploy advanced topologies for high availability and disaster recovery. And these are going to be database specific. Customized configuration and the ability to scale up and scale down. This could be memory and CPU, as well as storage, and potentially scale out in a sharded environment. One feature which can be really important, we get used to that in the Oracle world, is rolling upgrades and patching. Not all database operators do this, but it's just something we should be looking for. Database cloning, using our storage to be able to do this, and then automating the database side of it. Database security, so if you're deploying in the cloud, you want to be really looking at database encryption, secure database connections, and encrypted backups. Some of those requirements are also true to be on-premise deployments. Backup and restore, look at the database as a service operator, see whether it supports native backups. So for the Oracle world, we want to do RMAN. If we were using MySQL, we want MySQL done. PG backup REST for Postgres, etc. So we need to be able to do native backups so that the data is portable between containerized environments and non-containerized environments, physical environments and virtualized environments. Does the database as a service solution use storage snapshots or file system snapshots in the Kubernetes world? So we need to understand that. Application programming interfaces. Are you able to script this? Are you able to automate this in a larger framework? So APIs are really important. Monitoring, logging, and metrics. We need to be able to access our database logs, our audit logs. We want to be able to see backup logs. We want to be able to see the logs. We want to be able to monitor it. We want to be able to see the performance of our database, the performance of the Kubernetes infrastructure, and metrics. What's being captured, and whether we can export those metrics into through Prometheus and display those in Grafana, for example. And then notification services. So if something goes wrong, how will we know about it? The Kubernetes environment will self-heal, and it will restart a service on another worker node, but we want to get told about it. So notification services are important. When you consider a database as a service, whether that be physical, virtual, containerized, on-premises, in the cloud, we want a consistent way of working. So, we have expectations what our operators should give us. The Oracle Database Kubernetes Operator, the Aura Operator. So this was worked on last year. It's still version 0.1. So it's not production ready yet. And Oracle say this on their GitHub repository. But it has some interesting concepts in there. So rather than just managing a containerized database, the Oracle Database Operator on the roadmap is going to be able to manage on-premise databases, containerized databases, and we're talking about Kubernetes containerized databases, as well as Oracle containerized stroke pluggable databases. It should be able to manage all databases, on-premises, in the cloud, and autonomous databases. So today, supported configurations are databases in the Oracle Cloud and databases on-premises for the autonomous databases and shard databases. So it has, it's a project at the moment that's public, so you can visit that on the GitHub, Oracle-Database Operator, and you can see the code for there. You can see how it's been deployed, how it's been built up, and you can actually contribute to that project, lots of other environments. Where I see the operator really becoming powerful is that we'll be able to have one language using kube control to manage containerized database and non-containerized databases. And when you consider things like MySQL HeatWave or autonomous database, you'll be able to use Kubernetes to bring your application to the database. So removing data gravity. So rather than having to pull your data out of a traditional database and put that into containers, have that containerized, we'll be able to manage the database and application as an entity through kube control. So looking at the roadmap, what can we do with the database operator today? So autonomous database, single instance, Express Edition 2, XC, all available. Sharded, containerized databases available. And then planned on the roadmap, all of the other flavors of autonomous database, rack containerized databases, and on-prem, including Exadata. And then finally, Oracle will open it up to be available on other clouds with the extension for Oracle Rack, and then make it generally available by the operatorhub.io. Today on operatorhub.io, there are 38 different database operators covering most modern databases. Some databases having multiple operators. So if you look at Postgres, MySQL, you will see different providers having those operators there. Today, there is no operators available for Oracle other than the Oracle one, which is at the GitHub repository we just talked about. When we talk about databases and we talk about Kubernetes, we talk about observability. And Oracle is looking at this as embracing this. So Oracle has a Prometheus exporter, which can be used to take information out of the database, so metric data from the environment and the database, and then you can use that within your enterprise Grafana dashboards. So this is going to be really powerful. We'll be able to have a common dashboard now with metrics from our applications and our databases all from one place. So give us the end-to-end traceability that people are enjoying today with Grafana. So how do you use the operator? So in my OK environment in the cloud, I am using the UK London 1 region. It has free availability domains. Most of regions have free availability domains. Some have 2 though. So what I've done here is I've got an OKE engine running 1 worker node in each of the availability domains. I've got a Terraform script which automates the deployment, creating VCN, so the virtual cloud network, the subnets, the security list, the route table, the internet gateway, service gateway, network gateway. I also create a Bastion host so I can have it a level of protection. So I have to go onto the Bastion host to connect to my worker nodes. And then I deploy OKE. So my free worker nodes are built through OKE using the Terraform components there. And then I provision additional block storage to those worker nodes. And then I install Portworx across that to give me a software-defined storage to allow me to mirror data and replicate data across. So my OK environment looks like this. I have Kubernetes running in the region with free availability nodes. And we can use kube control here, get nodes, and I can use a topology label here so we can see the region and the London, which is really quite nice, really quite powerful. And the version, there's my nodes and the version. So I can see that they're in 3 different availability domains. I can also check the version of Portworx, by looking at the pxctl versus v. So I know I have environment configured. So okay, let's get ready to create a database using the operator. So I start by creating a namespace. So this is a dedicated namespace. I'm going to call it Oracle namespace. So I have a data file, a text file, a YAML file, yet another markup language, and I apply that using kube control apply -f. So, and then the file name. And that's going to create me a namespace. I then create some secrets. So we need to know our Oracle single sign-on. We need this to be able to access the Oracle container registry. And also we need to create a password for our database. So here I've created a secret for my database in the Oracle namespace. And here you can see the syntax of creating a secret for my OCR registry. So here I'm using container-registry.com rather than the Docker Hub, but it still requires the syntax is Docker username, Docker password. So this is actually my single sign-on for Oracle username, password, and email. So that's going to create me an environment so I can now log on to the container registry to pull back my image. I install the cert manager. So the certification manager is a requirement for Oracle's database operator to allow it to use webhooks and validating user input, managing the etcd. So kube control apply, and there's the -f, and we point that to the URL or the cert manager, and then that will install. To install the database operator, very similar again. We clone the operator back from the GitHub location. It's a public location. Same way we cloned the Helm charts. So here we have our operator pulled back, and then I can apply the operator to install it. So this is a one-off task. We install this into our cluster. The operator creates a namespace. It creates CRDs, roles, bindings, and an operator deployment. All of this is done fully automated for us. So I said this is a once-off activity. Once it's done, we are then able to start spinning up databases on demand. So we need to have a confile, which actually defines what we want our database to do. So we have to localize that. So there is an example file in the GitHub repository that you just pull back. So copy that into a local directory and then localize it. So I'd suggest you update the name, the namespace, the SID, the secret name, the secret key, your PDB name, the pull from, pull secret, size, storage class, and any other requirements. So here's an example of my file. So here you can see I've defined the database name, the namespace, enterprise edition, the secrets I've just defined earlier, and my PDB name. We also use a secret we created for our registry, and we tell Oracle where we're going to be pulling our image from. So this is location on the container registry. So I pulled back the latest version. And then I've defined a storage class, saying how much storage I want to allocate, and then the storage class. It's a single instance, so it's read write once. So I've created my YAML file. I've defined all of my database settings. And then very simply, we can create a database. We can vision a database with a single command, kube control apply, single instance database YAML, and then that's going to create me a database. We can then watch the progress of this using watch, kube controls, and then the custom CRD there, and then the name, and we can watch the state go from pending, creating, patching, healthy. Kube control get, single instance database -n, and then that's just going to keep updating. Here we can see the database name, version, edition, and the state. So the state we move from creating through patching to healthy. Once it's healthy, we connect to it. And it shows us the connect string and the OEM express URL. One thing that's really good to do when the database is creating is to watch the log files. So we used to do this with our database, so we can do the same in a containerized environment. So we identify our Oracle pod, and then we want to look at our Oracle log file. So here you can see I've got my kube control logs, and I'm watching this going through. So we can see the log file, and it looks the same as any other Oracle database log file. If we use the -follow, we can actually watch the progress of this. And it was like doing tail minus F. It will just keep on spooling to the end. Really nice. So I have my Oracle 21C database up and running on OKE. Can I check that? Yeah. So kube control IT. So I'm going to shell into my pod, and I can run SQL Plus with the username password that I've specified in my YAML file. I connect to my database, and I can see the version. And here you can see I've just done show PDBs, and there's the PDB name I defined in my YAML file. There's my instance and the host name, which is the pod name, not the worker node name, and then the version. All from one line. From one line of command, I was able to create an Oracle 21C database. We can use the operator to give us information. So here I'm using the operator to tell me the database name and the PDB name. So get single instance, and then we look in there for SID, look in there for PDB name. We can all use the operator to return the database and PDB connection strings. So here, connect string, PDB connect string. So we don't have to know all this information. Once we got it installed, we can just ask the Kubernetes environment to return this information to us. Now, I always advise to have stuff in code. So use infrastructure as a code rather than and have it dynamic rather than hard coded. And using kube control, we can do this. We can ask kube control to give us the database names, and we can assign those to Unix environment variables and use those in our scripts. So let me show you an example. So I won't do this live. It takes about 25 minutes for me to do this in OKE to pull the image back and deploy this. It only takes a few minutes to a lot less minutes to create the database, but still, it's let's just watch this play out, and I'll talk through. So here's my topology. So here's my 3 nodes I talked about. So I've set up a variable to look at the version of Portworx which I've installed, and here's my YAML file. So here I'm going to show you there's the database name, the size, the system volume, and that's that done. So here we're going to kube control get PVC. I've got no persistent volumes at the moment. I apply my single database YAML file, so that creates my database. That's going to create my services, going to create my persistent volumes, and let's just watch that change status. So it's stating pending, creating, and then that takes a while. The version's unknown at the moment. It's still building it. There's the database name. So this is an accelerated video to make it watchable. So it's moving through. So let's have a look at the Oracle logs while it's doing it. So I identify the pod and then describe the log file. So here we have our kube control log file. And if I do watch with a follow on it, I can see the progress. So here we have it moving on. It's at 36%. My single instance, it says it's creating, and here's the detail. So we can actually watch it create. So we can either wait for the status to come healthy, but if you're interested, you could just sit there and watch the creation. And this is what you would normally see if you're doing DBCA or other installation methods. So we can see it's moved on to 43%. It's created the database. Now it's going to start creating the pluggable database. See, they're creating pluggable database, and then it moves on, and you see the updated file. So it looks like it's almost finished here. Database is up, is ready, but it hasn't actually reported it's ready in the Kubernetes world. It says it's patching it. So it knows to patch it. So that's part of the operator. It's doing this for us. And it's going through the container and pluggable databases and getting them ready for us to use it. So it's gone healthy. It's now available. So to clear the screen, find the database name. There's to find the database name and the PDB name and the server name. I can create my own connection string from this now. Get the pluggable data. So I can set up variables and have those defined for me, so I can use those in scripts. So let's shell onto the database. And we'll have a look at our PDB names. And there's the PDB that we created with the YAML file. And there's the database name, and there's the instance name. And there's the connection string we can use to connect to the database. It's all very easy to use, all very powerful. So here's some cheats, really. So some clues to get you going, and some commands you might want to consider using. So kube control get pods to get us the pod name. No pod prefix, just get the name there. Get the operator name. So using the name from the data path, the metadata path. SID name, using the single instance database operator. That's the SID, PDB name, and status. So all of these can be returned from the operator. As you saw, the operator also configures Enterprise Manager, so we can connect to the Enterprise Manager and see that in use if you want to use OEM to look at your database. So I've got this fully documented at my blog, ronekins.com, so please visit there if you want to read more, or reach out to me on Twitter at Ron Ekins, and we can talk to this offline. I've also got the deployment fully automated with Terraformer, so you can go to my site and you can see the Terraform method, and also there is a link to the GitHub with the code made available there. We also have on my site how to install the 21 series of the Oracle Operator. So this is really the detailing what we just talked in this presentation, so you can follow that through, and also how we can use the operator to do failover between availability domains. So that's probably out of the scope of this presentation, but maybe it's one I'll repeat for you in a future event. So here we're using the operator and Kubernetes and the storage platform to actually have our data replicated across availability domains, so that if we lose an availability domain, our data is protected, and the Kubernetes operator automatically restarts the database in an alternative availability domain. So that's what I wanted to share with you today. I've set myself up now for a few minutes of questions. So let's see if there's any questions in the chat box. So, Kim, are the Oracle Docker images patched? So the Oracle Docker images aren't maintained. They are a point in time. So you see the release. So if there's any particular patches you require, you'll need to do those on top of those. So they are as per the versions of that release in time. So they're not having CPUs rolled into them. Are the DB Docker images meant for production? Yes. So as per the support item now, the Docker images are, and Oracle 19 single instance is fully supported in production. So you need to make sure you have the support contracts and licenses in place to do that. How does the rack Docker take care of the rack private networking requirements? So if you go to the GitHub, there is a walkthrough on how to configure Docker. So in the Docker world, you have to do this outside. In the Kubernetes world, it's a little bit easier. The networking is slightly different with Kubernetes. I haven't created a Docker rack environment, so that's on my to-do list. But I will do that in Kubernetes and manage it that way. How does one access the DBs in Kubernetes since the IP address is Emerald? Deploy a Kubernetes service for the client to access. So if you connect to for my desktop, if I have a multi-node cluster, I can connect to any worker nodes, and the node port will automatically route it to my database. So I'm not connecting to a particular node. the Kubernetes environment will know where it is, what node it's running on, and direct it to me through the services. What are the pros and cons in your view when it comes to Docker and Kubernetes, please? So, pros, it means we have our data containerized and make it more portable. One of the reasons we would want to containerize our database is for simplification, to have a consistent deployment model, to remove the need to install a server, patch it, maintain it, and have that repeated throughout all our test servers, production servers. If we containerize it, it's a known state, so it's a lot easier to deploy. So we get consistent deployment, whether that be on premises, in the cloud. So that's a big plus. It also takes the database and makes it more accessible for developers that are used to using now a Kubernetes environment and maybe aren't used to using SQL Plus or using Linux-based tools. They're talking kube control as their language of choice. What is in your opinion, is limitation versions maintained when it comes to Dockers? So, surprisingly to many, 5 years ago, if you would have said containerized database, you would have been probably an outlier. Today, 80% of the Kubernetes workloads are databases. That is heavily on the MySQL and Postgres side, but other databases also adopting containerization. And I can see, Oracle is working on this with their database operator. They're probably a bit late to the party, getting the operator out. There are operators for other databases, but what they are trying to do is have an operator that manages containerized and non-containerized databases. So it's taken them a bit longer. I think it's going to be really powerful when it does become fully GA for all databases in all places. I would definitely think it's the right time to learn containerizations. Limitations, they're probably all gone now. So if you had been a purist 5 years ago, they would have said containers are for stateless applications. With persistent storage, we're able now to have our data persist, be replicated between on-premises and in the cloud, and have our data protected. We're able to use backup tools and manage our databases the way we would in any other environment. So if we go back a few years, people have said, databases aren't a good fit for containers. They're heavy I/O. They need lots of memory, lots of networking, and they're persistent. They're stateful. Kubernetes has evolved, and it's now able to do database workloads. And I say, I was at KubeCon last week, and it's by far the largest use case now. So Babu's typing another question in. Do you think they get abused due to the way they can be spinned on the fly and destroyed? Yeah, you still need to have governance in databases. You can spin up a database on a server. You could spin up a machine using Vagrant on your desktop. So controls still need to be in place. You can use your PVCs, your persistent volume claims, to have it so that if you delete the database, it doesn't delete the data. So you could have those protected from error or from malicious intent. So you can use the storage to protect you there. You could use replication also to give you other protection. But I think we should get used to the idea of spinning up databases on demand, especially when we look at sort of cloud credits. You want to be able to stop and start services. So destruction. If you can spin up a database quickly and you can populate the database quickly, maybe destroying it isn't so much of a problem. But databases do normally hang around for months, if not years, whereas a stateless application may only be hours or days. Lots of questions. Let's make sure I've done them all. Great to see so many questions, and thank you very much for engaging with the chat box. It makes it a lot more interesting. So yes, thank you, Babu, for your insights. Yes, so thank you for the question. So hope you found this interesting. It is a new and emerging technology. We're seeing this in maybe being led by the open source database world, and so the MySQL side, which Oracle fully supports, is doing a lot there. But we will be seeing traditional database like an Oracle and Microsoft moving into containers as well and adopting it, I think, in the future. So it took us in the Oracle world probably 10 years to embrace virtualization with VMware. I don't think it's going to be 10 years for containerization, Kubernetes. It's probably we're looking at probably another 2 or 3 years before it's mature enough to run all our database workloads, but it's getting there very fast.
All right. Thank you so much, Ron. Looks like all the questions came through here because no one come from by Facebook. And thank you so much again, like yesterday, for taking the time to share your knowledge and experience with the Asia Pacific and the global community.
No, thank you for having me.
No,
I'll look forward to doing this again sometime.
Thank you. Thank you so much, everyone. This was the last session of this conference. Next month, we are going to have a time off of conference for the Apaco UC. We're going to have 1 month of rest, and then we will have more conferences coming online on July and August. Thank you, everyone. Have a wonderful evening, afternoon, or morning, depending when you are, and please take care and be safe. Bye-bye, everyone.